Hello, my registration number is ICTS 141 and I'm going to present my slides for the TICT 1134 ICA. So my topic is factorial calculation using recursion, and I will also compare it with the iterative approach in C++. And in this presentation, I will explain what recursion is, how it works, demonstrate the both recursive and iterative implementation, and finally I will compare the both approaches. First, let's understand what recursion is. Recursion is a programming technique where a function calls itself in order to solve a problem. Instead of solving the entire problem at once, recursion breaks it down into smaller sub-problems of the same type, and this makes the solution more elegant and closer to the mathematical definition of the problem. Now let's understand what factorial means. The factorial of a number n written as n factorial is the product of all positive integers less than or equal to n. For example, factorial of 4 is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 24. This can also written recursively as 4 factorial is equal to 4 multiplied by 3 factorial. 3 factorial is equal to 3 multiplied by 2 factorial, and so on until we reach 1. Recursion works using two important components. The first is the base case, which is the condition where the function stops calling itself. The second is recursive case, where the function calls itself with a smaller input. In the case of factorial, the base case is when the n is equal to 0 or where the result is 1. The recursive case is when the n is greater than 1, where the function returns n multiplied by factorial of n minus 1. If we don't define a base case, it can lead to a stack overflow. We'll talk about that later. Now let's look at the recursive implementation in C++. In this function, we first check if the value of n is 0 or 1. If it is, we return 1. This is our base case. Otherwise, we will return n multiplied by factorial of n minus 1. So each function call depends on another function call, and this continues until the base case is reached. All these functions are stored in a memory using a call stack. And once the base case is reached, the results are returned back step by step. Now let's look at the iterative approach. In this method, instead of using recursion, we can use a loop to calculate the factorial. We initialize a variable called result to 1, then we use a loop from 1 to n and multiply each number to the result. Finally, we return the result. One important limitation of recursion is stack overflow. No, not the website. Each recursive call uses memory in the call stack. If the number of recursive calls become too large, it can exceed the stack memory limit and cause the program to crash. Because of that, recursion is not always suitable for large inputs. Now let's compare the recursive and iterative approaches. The recursive approach is more readable and closely follows the mathematical definition, making it easier to understand, and also it requires fewer lines of code. However, recursion is slower because of function call overhead, and it uses more memory due to the call stack. On the other hand, the iterative approach is faster and more memory efficient since it uses simple loop and does not require additional functional calls. It also safer because it does not have the risk of stack overflow. However, it may slightly longer and less intuitive to compare to the recursion. In conclusion, recursion is a powerful and elegant technique for solving problems by breaking them into smaller parts. It's especially useful for understanding concepts and problems like factorial, Fibonacci, and tree structures. However, for practical application with large inputs, the iterative approach is the more efficient and reliable. And this is the end of my presentation, and thanks for listening.